So, have you ever really thought about what happens when one of your simple, everyday scheduled tasks, like processing orders every 10 minutes, suddenly gets thrown into the big, complex world of a modern cloud app? It turns out that super reliable task can morph into a hidden danger, a real ticking time bomb for your data. Today, we're going to defuse it. All right, here's our game plan for diffusing that bomb. First, we'll nail down exactly what the problem is in places like Kubernetes. Then we'll look at the elegant solution, check out some real-world tools, and most importantly, we'll master the configuration you need to build schedulers that are truly ready for production. Okay, let's kick things off with a scenario I'm sure many of you have seen. Your e-commerce app is a huge hit, it's growing, so you scale it up in the cloud to handle all that traffic. But right inside that success, there's a critical flaw just waiting for the worst possible moment to show up. Back in the good old days of single servers, a scheduled job was a piece of cake. One server meant one task ran right on schedule. Simple, predictable. But in the modern cloud, think Kubernetes, you're not running one instance, you're running many of them, called pods. And that same exact scheduling logic suddenly creates this massive race condition. Every single instance is trying to do the same job at the exact same time. Let's just walk through this disaster step by step. It's 10 a.m. Boom. All 5 pods wake up. They all hit the database, and what do you know? They all see the exact same list of pending orders. And before any one of them can mark an order as processed, they all start working on it. The result? You just charged a customer 5 times for the same thing. This is how you absolutely wreck your data and lose customer trust, fast. So how in the world do we fix this kind of chaos? Well, the key, the absolute key, is giving these independent pods some way to talk to each other, to coordinate. And the solution is a really powerful yet beautifully simple concept. It's called a distributed lock. I want you to imagine a talking stick that all of your pods can see. It's usually just a special record in a shared database. Now, before any pod can start its work, it has to try and grab that stick. And the rule is only one can hold it at a time. The one that wins gets to run the task. All the others, they see the stick is taken and just say, okay, not my turn, and go back to sleep until the next run. I mean, the difference here is just night and day. Without a lock, you've got a chaotic free-for-all that's just begging for data corruption. But with a lock, you get a predictable, orderly system where one and only one pod is chosen to do the work correctly just once. All right, enough with the theory. Let's make this real. We're going to look at a super popular Java framework, Spring Boot, and a library called shedlock to see how this works. But remember, the ideas here, the principles, they apply no matter what language you're using. So in the Spring world, making a scheduled task is as easy as adding this little @scheduled annotation on top of a method. That cron expression string you see is just a universal way to define a schedule. This one says, hey, run this at the top of the hour and then every 10 minutes after that. Super easy, right? But as we now know, it's also super dangerous on its own. Now, to make it safe, we add this one more annotation, this one from shedlock, @schedulerlock. This single line of code is the magic. It tells the system, hold on. Before you run this method, you have to go out and get the lock named myscheduler. That's it. That's the talking stick for our code. And we're going to dig into those other safety parameters in just a minute. But, and this is a really big but, just adding a library isn't enough to call it a day. It doesn't make you production ready. The real power, the real safety, it doesn't come from the code itself. It comes from how you control that code. And that brings us to what I think is the most critical part of building robust systems, configuration. So why is it such a terrible idea to just hard code these values right there in your annotations? Well, imagine it's 3 a.m., the pager goes off, and you realize there's a bug in a job. You need to shut it down, like, right now. If it's hard-coded, your only choice is a frantic code change and a full, risky redeployment of your entire application. Not good. But when you pull that configuration out of your code and put it into a separate properties file, you gain superpowers. You can instantly disable a broken job. You can change its schedule on the fly. You can tweak how much work it does, all without a single code change. You start treating your schedulers like features you can turn on and off with a switch. The professional best practice way to do this is called the feature flag pattern. Here's the rule. Every single new scheduler you write must have an enabled flag in your configuration file, and its default value must always be false. This is your failsafe. It means a new job does absolutely nothing until you make a conscious decision to turn it on. And when you're finally ready for that job to go live in production,
You just go into your configuration and flip that switch from false to true. That's it. No code change, no deployment. This gives you incredibly precise, granular control over your system without all the risk and ceremony of a full release cycle.
Okay, remember those lock durations we saw a minute ago? It is absolutely vital that these are configurable too. Think of lock at most 4 as your emergency release valve. If the server holding the lock crashes mid-task, this guarantees the lock expires after 30 minutes so another server can pick it up. And lock at least 4 is a cooldown. It prevents a super fast job from running over and over again if there's a weird clock sync issue between servers. Together, they are your critical safety net. So let's put this all together now. You've written the code, you've put in the distributed lock, you've externalized all your configs. How do you actually deploy a brand new scheduled job into a live production environment with confidence? You follow a strict, disciplined playbook. Step 1, you deploy your code with all the new feature flags set to false. The new jobs are dormant. Step 2, after you verify the application is stable, you turn on just one scheduler. Then you watch. You stare at the logs, you check the metrics. Is it behaving? Is everything okay? Great. Then and only then do you move on to the next one. This incremental rollout is what prevents one bad job from causing a system-wide outage. And that really brings us to our final thought. As our apps get bigger and move into these complex, distributed cloud environments, it's so important that we re-examine even the simple things. So, you have to ask yourself, the automated tasks that my system relies on every single day, are they actually built for the reality of the cloud? Or are they a disaster just waiting to happen?